Okay, but if we are going to use vector form, okay, and then we know what we're going to find is our omega AE, right? Now, in fact, now we can use your gear ratio that you have learned, right? I'm trying to recall my gear ratio over here. Does it work? I think it will work. Can you use your gear ratio knowledge to calculate what is omega AE? And tell me what is it? Come on, use what you learned in your design course. What do you get? Any idea? So the distance over here, this is what? This is equal to 0.2. No, this is equal to, wait. This is equal to 0.2. And this over here is equal to 0.3. So given the radiuses, can you all calculate what's omega AE? Hey, how much? 135. Somehow the answer is different from mine. Okay, let's do what we need to do. Okay, so to calculate, we are going to use we are going to consider the sun gear. So we are going to consider member AE. Okay, we're going to consider member AE. So by consider member AE, we have what? We have velocity at A equal to velocity at E plus by omega AE cross R A from point E. Okay. So what we know that VE I, this is also VE J, they are all equal to 0, right? So VA, so at this instance over here, VA is in one direction only, right? So VA is going up in this direction only. Okay, so this is our VA, right? So VA J, we know there's no I, is equal to, so VE we know is equal to 0 plus, so omega AE will be positive because it's going anti-clockwise. So R from point E is equal to 0.2 I. Okay. So we form an equation, we have VAJ is equal to omega AE. So 0.2 K cross I is positive, right? So it's 0.2 omega AEJ. Okay. So from here, based on J component, we have found that VA is equal to 0.2 omega AE. Okay. So now we have to find what is our VA. Okay, we have to find what is our VA. So VA, we can use what? We can use this, so we know that VA, right, is equal to what? Is equal to 0.3, or I'm going to write this out. So if we go back to the diagram, right, where the thing mesh, right? And this gear is pretty confusing. You have a B and you have A, and we know that VA has to be equal to what? VB. We can directly calculate what is VB. I'll put down here, right? So VA is equal to VB, and this is equal to 0.3 multiplied by what? 90. So 0.3 multiplied by 90 is equal to, is it 0.3 or 0.4? Wait. My eyes are failing me again. Yeah, it's 0.3. Okay, so 0.3 is equal to 27. So velocity at point A, or omega AE, is 27, is equal to 0.2 omega AE. Okay, so let me check again. 0.3, correct. Yep. So finally, omega AE, 27. You are right. 135 radians per what? Second. But you can use your gear ratio. So, but I'm not teaching gear ratio over here. Okay, I'm teaching vectors. I tend to go slow on this problem because I want you all to be clear. Okay. So the most important thing, note. Okay. The most important thing is what? When two gears, when two gears are in mesh, the linear velocity is the what? It's the same. Okay. So this is the most important thing that you learn here. Okay. So not that bad, not that difficult. Okay. When you understand the concept, okay. The concept is two gears are mesh, and also they will tell you the boundary condition. Now you can see how critical the what boundary conditions are. Okay. Now let's do, I think this is one of the worst gears question I've seen. Let's do this one then. Okay, so you have, holy shit. It looks a lot, okay? Am I right? When you first look at it, like, this is quite a bit, but as I said, it's not that bad, okay? Right, so let's look at this question. Planetary gear system, so this is example number 2. I think in the textbook, again, this is one of the most difficult, or not difficult, complex question that you see, but it's not that bad, okay? So he says, right, the planetary gear system is used in an automatic transmission for an automobile. By locking or releasing certain gear, it has the advantage of operating the car at different speed. Okay, right. So consider the case, okay, so we are consider the case where the ring gear is held fixed. So now we are given a boundary condition where omega r is equal to 0 radians per second. Okay. And the sun is rotating at omega s is equal to 5 radians per second anticlockwise plus by 5k radians per second. Determine the angular velocity of each of the planetary gear P. So we have to determine the angular we have determined the angular velocity of the planet gears and shaft A. So what we don't know is shaft A. So we don't know what is omega A down here. And we have not a clue what is our omega P. Okay, so that are the things that we don't know. Right. So once we see the diagram like that, don't panic. Okay, it looks 3D, but it's not that bad. Okay, so we declare over here X, Y, and Z. Okay, and this is basically using our right hand rule, right? So this is our I direction, J direction, and K direction. Okay, we declare that first. So now the diagram seems to be really crowded. Okay, really cluttered. So we are going to make the diagram not so cluttered. Okay, because there are some things that we can get rid of. Okay, there are some things that we can get rid of. So we can yeah, we can get rid of the clutter. So we know we are going to focus now on so we have a come on, get this to work, Eugene. Okay. So this is the center. So this is over here, this is our sun gear. Okay. And then we have a planetary gear. And this planetary gear, wait, how come it's not working now? Sits on top. Okay. And the only thing that is given to us is omega S is rotating this way. Okay. Now, is it very obvious that omega P will be in this direction? Yes or no? Right? You all agree or disagree? Right? It has to like oppose. If you look at the gear, when they mesh, it has to oppose one another, the angular rotation. So over here, if you are sure, you don't quite assume. You are very what? You are very sure. Okay. So over here, we can generate right. And this is our VS, which is equal to our what? VP. Where S denotes the sun and P denotes the planet. Okay, where VS is equal to VP. And at this instance over here, right? At the I'll draw a different dot, red dot. We over here, we know at this point over here, VR is equal to 0. And R denotes the ring gear. Okay. And we know that the ring gear is what? Is fixed. Okay. We know that the ring gear is fixed. So these are all the, I hope these are all the information that we need. Okay. What I propose is we go for 5 minutes break. Okay. And then we come back again. Take a 5 minutes break.